Alright, so here we have this sequences frame. It talks about the sequences, the types of sequences, and the equations. So this is what it looks like blank. Okay, and you can get it from my website if you need it, which is myuen.org/myuen/221804. And if you just go to the Math 1 tab, page tab, whatever, you'll be able to download it and use it. Okay, so this is what it looks like. Okay, so you're going to want to probably pause and copy down these. Okay, looks like I think we started probably with this one. That's typically what I start with, but it doesn't matter. Okay, either one works. So I'll zoom in on some parts, and you're probably just going to want to pause it when I zoom in and take a look at it that way. Okay, so key topic, types of patterns, okay, the arithmetic and geometric patterns and how they grow. So the first one is the arithmetic. Okay, they grow by repeated addition or subtraction. We also say it grows by equal differences over equal intervals. And we call that growth, we call them common differences. Okay, and here's some examples of the table where we see that growth, okay, from the outputs. Also, as a sequence, what it would look like, again, we see that repeated addition or subtraction, kind of what it would look like in a contextual story problem, maybe how it would look as a picture, okay, and then the recursive and the explicit equation, which we'll go more in depth on that other one, okay. Also, we will specialize in the arithmetic sequences, and eventually we'll start talking about linear functions, okay. And here's some ways we see the linear function equation here written up, and kind of how we see it visually and as a table, kind of that same information. Yeah. All right. Then looking up here at geometric, okay, they grow by multiplication or division, though we even change the division often to multiplication. We also say it grows by equal factors over equal intervals, and we call that growth the constant ratio. Again, a table of examples. See the multiplication as a sequence, the multiplication, maybe something what it looks like as a story problem, a contextual, okay, a picture, what the recursive and the explicit look like. And we will get into a type of function that deals with the geometric sequences, which is an exponential function, kind of how they look, more curved, not a straight line, and some information about those. All right, so again, if you need to, go back and pause it so you can copy that stuff down. Okay, looking at the frame on the other side. Okay, now let's talk about the type of equations. Okay, so this is about writing recursive and explicit equations. Given, we're focusing on knowing the zero term or the starting number and how it grows, okay, which we kind of already talked over here, right? Oops, made that way too small now. Okay, we talked about that information. So, looking just at the recursive. So the recursive looks like this for the arithmetic version. A sub n equals a sub n minus 1. That a sub n is our next output. A sub n minus 1 is our previous output. Okay, plus or minus, since it's arithmetic, that common difference. Okay, and then we also need to know where it starts. A sub 0 is that zero term. The n is represented by the input, but we only need to know that for on the table to know what the output is. And when we think about recursive, it's connecting outputs, okay? And it's kind of how we build and see patterns. When we build them, we take the previous, apply the growth, and that's how we get the next. Well, the recursive is great at doing that. Okay, some other formats we may see, instead of n, we may see x as the input, maybe f of n instead of a sub n, or f of x instead of a sub n for the next output, then the n minus 1 to represent that previous output. Okay, that takes us back kind of looking at this table, the idea that the next, to get the next, the fifth term, I've got to go back one to know the previous and then apply the pattern. Okay, and that's what the recursive is all about. So it could look like this with the f of n, kind of that function notation, or x. Okay, you may also run into instances where we use a sub 0, that's our starting number. Sometimes they'll use a sub 1. Okay, that's another good starting number. You just have to remember that you have to go back. If you're switching to an explicit, it's easier to go back. Okay. Sometimes I've also seen the next input as n plus 1 and the previous is just n. Okay. So but the minus 1 plus 1 just moves it up and down on this table. That's all that deals with. Okay. All right. Now looking at the explicit equation. Okay, the explicit as arithmetic, right now we're using a sub n equals that start number, that 0 term, plus or minus the common difference. Then that repeated addition we represent with multiplying by the variable. Whereas geometric, we'd still start the same way, but instead of addition, it's multiplication. And even if it's division, we change it to multiplying by the reciprocal. And then that constant ratio raised to the power, because repeated multiplication, we shortcut with a power. So the a sub n still represents the output. N represents the input. Notice now that we just have an n here, because this connects the inputs to the outputs. Okay. The reason we like that is because it uses the pattern, so we don't need to have that previous output, especially the higher up we get. Okay. Other formats we may see, we have the a sub n for our output. Could do f of n, f of x, even y. We see it a lot, especially with graphing. Inputs generally n or x. Technically, those numbers could, or variables could be anything else. Okay, that should be familiar in the arithmetic, slope-intercept form. Also written more in this format, which is matching how we like to think about it. Okay, even f of x, geometric, we see it like this. Sometimes you'll also see they'll do an n minus 1. Okay, and to kind of just model that, if we have this situation here, I like to go back to the 0 term. Okay, and so 3 times 2 to the n, because the n matches what number we do. But if we decide to not go back to the 0 term and start with the first term, okay, you need to match it up. You have to do the n minus 1. Okay, so sometimes you may see that as well. But that's basically what we got going on here. Okay, and there's your frame. Make sure that you get the whole thing in for both sides. And there we go.